right? The next concept that we need to understand is the concept named as electric field. Right? As I'll explain it before pause now. And the book order, I'll go in my order. Easy. Okay. So electric field. Now, I think we have already discussed about this. Name of the chapter itself is electric charges and fields. So what field are we talking about? Electric. Right. Now, suppose I have a charge here. Right? I have a charge here. So if I try to place another charge closer to it, what will it try to do? It will attract or repel. It will exert a force on the neighboring particle. Right? So can we visualize it in a different way? If this charge which is at this position, which is exerting a force on the neighboring particle, will this create a region around itself where you try to bring another charge, it will start experiencing force? Are you able to understand what I'm trying to say? Means this charge will start building a region around itself. So it will start building a region around itself in such a way that you try to bring in any other charge, it will start experiencing force. So this region that is built around this charge is what is called as electric. And any region outside this electric field is called as infinity. So we use this word infinity in the first part of next chapter. So remember, okay? So infinity doesn't literally mean infinite position. It is outside the influence of electricity. Am I clear? So having said this, can we give a definition to this? So based on whatever we discussed, can we try to put it in a definition format? So what is electric field? It is a region around whom? Around the touch. Where its effect can be felt on whom? On any other charge that is brought into it. On any other charge brought into it. Makes sense? So basically, electric field is a region around whom, around a charge, where you try to bring in another charge and start experiencing force. That's the simplest definition that is possible. Okay, we call it a region, some people call it as space. Because it can be in 3 dimensions, it can be anywhere here also. See, since I drew it to the board, it is looking like a circle, but actually it will be in the spherical form. It can be here also, because this can exert a force here, anywhere. Right. The next important question that arises is, okay, if there is something like this existing, is there a way where we can quantify it? Means, is there a way where we can find the value of its strength? Right. So that is what we call it as electric field intensity, which is represented with the symbol E. We'll see at the end. So it's called as electric field intensity. So name itself is suggesting. So don't get confused here. Electric field simply means a region. Electric field intensity means the strength of the region. Okay. Now, I'm not going to give you the definition directly. Let's think of it, then we'll frame a definition. Okay. The same logic. I have a region around it. Right? So let me call this charge as Q. So this charge Q has a region around it. Means beyond this region, it cannot influence any other charge. Right? Now I want you to logically tell me one thing. If this charge Q is replaced with a charge of 5Q, for instance, Okay, I have intensified the magnitude by 5 units. Whose magnitude? The charge magnitude, right? Now, let's say I have a charge Q naught in my hand, which is very, very small. Now, if I bring this Q naught into this region, and if I bring this Q naught into this region, in which region do you think it experiences more force? Where will it experience more force? How? Where did you see that? I have to ask you about force. Obviously, in the second, because this charge will create a greater electric field. See, its magnitude is more, it will create a greater value of electric field around itself. Am I clear? So, having said this, these kind of charges which are producing the electric field around themselves are called as the source charges. What are they? They are called as the source charges. And the ones that you are trying to bring into the electric field are called as test charges. And test charges by default are always positive. Always positive by default. But sometimes in the book, if in a question they say it is a negative charge, then you need to consider it. If they have mentioned nothing about the test charge, what is that you need to take? You should understand that there's positive. Okay. Now, when I bring this test charge into the electric field of the source charge, right? So first thing that you can see is this test charge will experience a force. Due to whom? Due to this Q. But I have a question. Will the source charge also experience a force due to the test charge? Yes, it will. So for the source charge to not get influenced, what we need to do is we need to take the value of the test charge to be as small as possible. You need to take it as small as possible so that the test charge does not create any impact on the source. Am I clear? Is the story clear to this point? Now, if I am able to calculate the amount of force experienced by the source charge, experienced by the test charge, and divide it with the magnitude of the test charge, where the magnitude of this test charge is almost 0, means it's a very, very small value. Then this particular quantifiable value is what we call it as electric field intensity. Are you able to understand how the definition actually came? So first, we are saying it is experiencing a force, right? That force, if you divide it with the charge which is experiencing the force, then that value is called as the electric field intensity. So this is the mathematical definition. It's a very, very simple thing. Am I clear? First, make a note of this. Give a definition to this. See, for you, I'm actually doing everything in reverse. First, I'm giving you mathematical expression, then I'm giving you definition. Know how to recollect if you forget also. Okay. So I have a question. If I say speed of the object is 5 meters per second, so how do you define? Okay, let's take velocity. How do you define it? Rate of change of displacement. You can say change in displacement per unit time. Both are same. Rate mixed with time. So rate of change of displacement is one way. Or you can say change in displacement per unit time. So in physics, whatever is written in the denominator is given a suffix called as per unit. In a similar way, how do you define this electric field intensity? You're talking about the SI unit. I'm talking about the definition. I didn't give the definition at all. I gave you the mathematical expression. But we need to define it. We need to understand what it is. Can you try? So look at it. Look at the way I'm going to write it. It is the amount of force experienced. So because that's what the numerator says. It is the amount of force experienced. Now the next question is, who is experiencing the force? By a unit positive test charge. Am I clear with this? This is what the definition is. So it is the amount of force experienced per unit positive test charge. You understood why that per unit is coming? Because something written in the denominator according to physics is given a prefix called as per unit. So this is the definition. Now, looking at this, can you tell me what is going to be the SI unit? Sorry, Newton per coulomb. Okay, in the next chapter, you will have another unit also. We'll see it at that point. It has 2 units. Okay, and the next important point is electric field density is a vector quantity. Electric field intensity is a vector quantity. It has a direction associated. So how to find the direction that I'll explain. So till here we can. Now shall we see how to find the directions?